Sabre is a concept under development by Reaction Engines Limited for a hypersonic recooled hybrid air-breathing rocket engine. The engine is being designed to achieve single stage-to-orbit capability, propelling the proposed Skylon space airplane to low Earth orbit. Sabre is an evolution of Alan Bond's series of lace-like designs that started in the early mid-1980s for the Hot Cold project. Inlet edit. At the front of the engine, the concept designs propose a simple triaxisymmetric shock cone inlet which compresses and slows the air to subsonic speeds using two shock reflections. Accelerating the air to the speed of the engine incurs ram drag. As a result of the shocks, compression, and acceleration, the intake air is heated, reaching around 1000 degrees Celsius at Mach 5.5. Bayer and Chemie, through ESA, have undertaken work to refine and test the intake and bypass systems. Precooler edit. As the air enters the engine at supersonic or hypersonic speeds, it becomes hotter than the engine can withstand due to compression effects. Jet engines, which have the same problem, but to a lesser degree, solve it by using heavy copper or nickel-based materials, by reducing the engine's pressure ratio, and by throttling back the engine at the higher airspeeds to avoid melting. Single stage to orbit space airplane, such heavy materials are unusable, and maximum thrust is necessary for orbital insertion at the earliest time to minimize gravity losses. Instead, using a gaseous helium coolant loop, Sabre dramatically cools the air from 1000 degrees Celsius 830 degrees Fahrenheit, down to 150 degrees Celsius in a counterflow heat exchanger, while avoiding liquefaction of the air or blockage from freezing water to port. The counterflow heat exchanger also allows the helium to exit the engine at a sufficiently high temperature to drive pumps and compressors for the liquid hydrogen fuel and helium working fluid itself. Thanks for watching.